What is it about what I'm about to write down What is it about what I just wrote in red that allowed me to do what I did? What are the properties of that equation that allow me to get to that answer without even thinking about it? Why was I able to do what I did? It's multiplication of what? The same base. I know my exponent rules. Same thing what you two just said, right? They're the same base, so I can multiply them together, yes? Now, we have already established that exponents are related to radicals, aren't they? Right? Because if I were to give you this, the root of 2 squared times 3 squared times 5, you would know you could take out the 2 and you could take out the 3 because those are groups, right? So we're all aware that exponents and radicals are indeed related, yes? And we know that if the bases are the same, I can do work with it, right? So if I had this, I can't do any work with that, can I? That's x cubed, y cubed, because the bases were different. Everyone agrees? All right. Well, what do you think in a radical, because remember, a radical looks like this, m root x. Where do you think is the part of this that is related to exponents? Is it the m or the x? It's the m, isn't it? Because that's how we know the size of group to take out. So if the m is what's related to exponents, and if I have the same base, I can multiply exponents, what do you think I have to have before I can multiply radicals? The same index number. I can only multiply radicals if they have the same index. Now, once I've shown you that, and once you understand that, that means to do what we're about to do, you need to see one thing. Tell me what is similar between the two expressions I'm about to write down. 2 root 3 and 2x. What is similar about those two expressions? They both have the 2. What do you call that 2? It's a coefficient, right? What does that mean? Right, 2 times x. What does that mean? 2 times the square root of 3. Everybody's cool with that, right? Okay. What happens if I do this? 2x times 2x. What do I get? 4x squared. Why do you know that? 2 times 2 is 4, and x times x is x squared, right? Okay. That's the one thing I need to show you, because now all of you should be able to tell me what 2 root 2. Now, what would that answer be? Do you think? 4 root what?
5.
Root 5? I have 4 root 5 and 4 root 6. Which do you think is correct? I haven't taught you how to do it. I've only shown you this. How did I get to x squared? I did x times x. And I told you that this and this are very similar. So if I did x times x to get x squared, what do you think I should do with 3 and 2? Multiply them to get what? 6. That's the right answer. And that's it. That's all you need to know to do this. Just like with letters that you learned in grade 9, It's the same thing here. So what am I going to do with the two things that I've highlighted yellow there? The coefficients. You're going to multiply them. What do you get?
35.
What kind of 35? Negative 35. Then what are you going to do with the two radicals? Multiply them to get what? 24. Not too difficult, is it?
Is that all you do?
Just wait. Is that very difficult? Does everybody follow it? Okay. Now, think back to 2 lessons ago. Are we ever allowed to forget math? Or does everything we've learned from grade 1, kindergarten, apply to now? Sure it does. If I ever showed you root 24, if I showed you that 2 days ago, 2 math days ago, not 2 calendar days ago, so don't do the joke that you would all be stuffing your face with Easter candy instead of doing math. If I showed you that 2 classroom days ago, what would you do with it? What would you do with root 24? You would simplify it, right? How? By breaking down 24 into what? To get out the groups of 2. I would say that's 4 times 6. Why? Because 4 times 6 is 24, and 4 has what? It's got a square root, right? So what comes out of there? 2. What was already out there? Negative 35. What do those both become? Negative 70. Why?
Because 2 times 35 is 70, but there's a negative, so I have to switch it to negative.
Negative 70. And what did I leave under the radical sign? Why did I leave 6 under there? Doesn't have any pairs. It's 2 times 3. Complicated? Multiply, simplify. Complicated? I don't think so. What are you going to do with B? What's the number out in front that we don't write? 1. So what do I do with that and 3? Multiply. What? So what's 1 times 3? 3. What do I do under the radical sign? Multiply. What's 2 times 8? 16. Would I leave it that way? Why? Doesn't 16 have a square root? What is it? 8. 4. So what comes out? 4. What's already there? What's 4 times 3? 12. Did I leave anything under there? No. So there's my answer. Any problems? Pretty easy, right? Just like 2x times 2x. So, what am I going to do with C? Same thing. What do I do with the negative 8 and the negative 6? Or the negative 8 and the positive 6, sorry. Multiply to get what? Negative 48. Root, what do I do with the 6 and the 12? To get what? 72. Would I leave it that way? Why? 72 breaks down, right? I break it down as 36 times 2. Why? (72) divides by 2 to 36, and I stopped at 36. Why did I stop at 36? Got a square root. What is it? So what comes out here? What do I do with 6 and 48? Multiply them to get negative 288 root 2. What if you're bad at this? You don't have your perfect squares memorized. Can you not do this? Of course not, but it will take you what? A little longer. Will you get there? Yeah, absolutely. Look at D. What do I do with the 3 and hey, there's nothing there. What do I do? So 1. So I get 3. Now, what do I do with 3 and 3? Multiply to get root 9. What is the root of 9? So what comes out? 3. So I got 9. Did I leave anything under there? No. Now, right now, you should already have seen something. What happens when you take a radical and multiply it by itself. You get your group of 2, don't you? So that should tell you that the root of x times the root of x equals the root of x times x, which equals x. Anytime you square a radical, you get the answer. Or you get the radicand back. Everybody cool? Now look at E and tell me what's different. There's some adding in the middle of it, right? Apply what you already know. If none of this was there, would you know what to do? What would you do with that? What would you do with the 5 and the 3? Multiply to get 15. What would you do with the 8 and the 2? Multiply to get what? 16. Then you would simplify. What's the square root of 16? So what comes out there? 4. And what would I have? 60. Correct? Everyone agrees? Okay, but that's not what I have. I have 3 things in there, right? So how many times do I got to simplify? Or how many times do I have to multiply? 3 times. So now I've already dealt with the 3. Now I got to deal with this one. What do I do with the 5 and the 2? What do I do? Multiply to get 10. What do I do with the 8 and 3? I should put it up here. 10 root 24. Would I leave it like that? Yes or no? Why not, Ethan? Or are you just shaking out your long flowing locks? You're just making fun of us guys that are going bald like that?
Yeah.
Right where I can see you just flinging your hair around like that?
Yeah.
I see. Okay. But seriously, what would you do with 24? Why? Because you can. What is it? We've already done 24 today. 4 and 6. What comes out? 4? Square root of 4. What comes out? 2. What's already there?
20.
So I end up with 20 root 6, yes? Then I got to do this with the last one. 5 times what? 1, because it's negative 5, right? And what's 8 times 5? 40. What would I do with 40? Break it down into what? You could use 8 and 5. I wouldn't. Because neither 8 nor 5 is a perfect square. 10 and 4. What's the square root of 4? So what comes out? 2. What's already there? So it's minus 10 root. What did I leave under there? 10. Now, do you already know what to do there? What method did I use to explain to you how this worked? I used x's, correct? So isn't this similar to 60 plus 20x, yes? Minus 10, is that the same as 6? So can I put an x there? What would I have to put there? A y. Could you do anything with that in grade 9?
No.
Why?
None of them are.
They're not like terms.
Yeah.
So can you do anything with that in grade 10?
No.
No, because they're not like terms.
But if you had 2 of them that had the
Same
same,
radicand,
yeah, then you would
what would you do?
add the outsides.
Yes, you would.
But you keep the
Because you already know how to do that in math, and math stays the same.
keep the radius something the same.
Yep. So let's look at this one. What's different about f? It's cube root, but we've already established today that cube root doesn't change our method, except we write a cube root instead. So, are there any coefficients? No, 1 and 1. So what do I do with 16 and 54? Multiply them together, and that would be 864. And then I would have to break that down, wouldn't I? Right? Does that make sense? Okay, should you do that? Let me ask you this. What if I gave you this fraction question? How many of you would go 12 times 49 and 84 times 144? And how many of you have been in one of my classes before and would say, hey, wait a minute, 12 and 144 breaks down into 1/12. 49 and 84 breaks down into 7/12. 1 times 7 is 7, 12 times 12 is 144. Anybody that's been in one of my classes before has seen this. What did I do before I multiplied? I simplified. So what could I do here before I multiply? Simplify. Simplify the question, if possible. Well, let's see if we can. Cubed root of 16 times cube root of 54. Is there a cube root that goes into 16? What? I don't know, Mr. Myers. So break down 16. It's 2 to the 4th, isn't it? Yeah, there is. 8 times 2, right? What's the cube root of 8? Yes, it is 2. Ethan, well done. You could have said that out loud. What's the cube root of 8? 2. Cube root 2. 54. If you have your squares and cube roots memorized, like I told you to, this makes it very easy. But obviously many people don't. So you take 54 and you break it down. Into what? What's your first two factors? 6 and 9, Louis says. Then what? 2 and 3, 3 and 3. Is there a group of 3 there? Right there. So what comes out? 3. And what stayed under there? 2. Now, is this really easy? What do I do with the coefficients? Multiply them. 2 times 3 is 6. Cube root. What do I do with the radicands? What do I do? Multiply them. What's 2 times 2? 4. And then I'm done. Which was easier? Simplifying these guys or simplifying 864? Yep. So what are you going to do with G? Are you allowed to go 15 square root 1,764? You're allowed to. Does that make sense? Why would you do that? Why would you simplify a giant number like that when you could just simplify 28 and 63? What does 28 break down into? No, I don't need a group of 5. That's not an index. That's a coefficient. What does 28 break down into? You could use 14 and 2. I would use 4 and 7. Why? Because 4 has a square root. So what comes out? 2. There's already a 5 out there. So what do I have? 10 root 7. What does 63 break down into? Sucks not knowing your times tables. If only Mr. Myers hadn't said it at the beginning of the year. 9 and 7. What's square root of 9? 3. So what comes out? 3. What's already out there? So that's 9 root 7, yeah? Now what do I do with 10 and 9? Multiply them to get 90. And root 7 times root 7 is the root of 49, right? What is the root of 49? 7. So what comes out here? 7. What's already out here? 90. So it's 630. Did I leave anything under there? Nope. Did we actually learn anything new today? We already know to simplify, and we already knew that when we multiplied coefficients and something else, we keep the coefficients together and the something else together, right? So did you actually learn anything new today? No, but you put together 3 other lessons of math to do further math. Does everybody see what is happening here? Right? We're not learning new stuff. We're just putting it together. Right? Math is Lego. Right? You can build the Statue of Liberty with the right Lego bricks. One Lego brick's easy to work with. Building the Statue of Liberty is a pain. You guys are going to do the first 5 on page 102 right now. I am going to put up the answers in a couple of minutes. You're going to work with your neighbor. You're going to work by yourself. You're going to look back at your notes. You're going to ask me, or you're going to ask Bryce, who's volunteered his time. And you're going to do those first 5 questions. Go. Okay. No, we're just going to talk about the first one. Because, as always, these are carefully crafted to take you from something you can work almost in your head through. What do I do with the 10 and the 9? Multiply, 90. What do I do with the 5 and the 5? Multiply to get 25. Don't I know the square root of 25? 5. So a 5 comes out here. 5 times 9 is 45 plus the extra 0. Easy peasy lemon squeezy. Now, if you are just memorizing steps, your first move on number 2 is to do 7 times 2 and 54 times 6, yes? 54 times 6 is a big number. So what could you do first if you are actually thinking about what you're doing and not just learning steps? You could simplify 54 because we know 54 is 9 times 6, don't we? What is the square root of 9? 3. So what comes out here? So I got 21 root 6 times 2 root 6, yes? What do I do with 21 and 2? To get 42. 6 times 6 is 36. The square root of 36 is what? 6. So out comes a 6. 6 times 42 is 252. Is everybody okay? Okay. What would you do with 3? You would simplify first. Why? They're big numbers, and because you can. Why wouldn't you ever not want to simplify? The word means make it simpler. Since all of you find math difficult, why wouldn't you do the thing that makes it simpler? Right? Can you simplify 15? 5 and 3. Any pairs? No. Nope. So I can't fix up 15. Can I fix up 27?
Yes.
Into what?
9, 3.
Why did you use 9 and 3, Louis?
Because the square root of 9 is 3.
So I can bring out a 3, right? So now I've got root 15 times 3 root 3. Now, what do I do with the 1 and the 3? 9 root 3, yes. What do I do with the 1 and the 9? Multiply to get 9. What do I do with the 15 and the 3? 45. Would you leave it that way? Why? Because that's 9 times 5, right? So what's coming out? 3. What do you do with the 3 and the 9?
Multiply.
To get 27. And what did I leave under there? 5. Now everybody should be ready to attack 4 and 5. Go. There is no excuse now for. It is 360. All right. What should we do here? Simplify. Which one? You can do both of them. What would you do with 20? 4 and 5. What happens to that 4? Comes out. So I get 6 root 5, yes? Right? Okay. What are you going to do with 45? 9 and 5. What comes out? 3. 3 times 4 is what? 12 root 5. What's 6 times 12? 72. Root, what's 5 times 5? Don't I know the square root of 25? 72 times 5. What's 70 times 5? 350. What's 2 times 5? 10. 350 plus 10? 360. What's different about 5? It's a cube root, and there's 3 things to multiply together. But does anything else change? When there was 2 things to multiply together, we kept our coefficients together, right? So what will I do when there's 3? Do you think? The same thing, right? Just because 3 times 2 is 6, 3 times 2 times 2 must be 12. Cube root. What do I do with, hey, wait a minute, 16, 4, and 2? Those are pretty big numbers. Could I do something? I could have simplified at the beginning, couldn't I? Or I can simplify at the end. Right? If I went 3 times 2 times 2 without thinking and just said, oh, coefficients go together, then I'm kind of stuck, aren't I? I have to keep these numbers big. I have to go 16 times 4, which is 64, times 2, which is 128. Then I got to break that down. Barf! It's a big number. So what should I have done first? What should I have checked for, Ash? Can I simplify any of those? Just the 16, because that's 8 times 2, correct? What's a cube root of 8? 2, so out comes a 2. Now I've got 6 cube root 2 times 2 cube root 4 times 2 cube root 2. Now it's super easy, isn't it? What's 6 times 2? 12. What's 12 times 2? 24. Cube root. What's 2 times 4? 8. What's 8 times 2? 16. What do I need to do there? Simplify. We already simplified 16. It's 8 times 2. What happens to that 2? Comes out there, so I get 48 cube root 2. Everybody good? Go. Keep working. There's 6 more on this page alone. Then I'm going to give you some work to do.
Did you ever have someone say to break down the factor tree and just multiplying by 1 a bunch of times? It's like, well, then it just becomes 0.
No. Remember, you know what to do if that's not there, and you know what to do if that's not there. So put it together. What's the first one going to be? He waited patiently. Just that part. What's that part going to be? 4 root 21. Then,
Does it matter for this?
what?
Bed mass doesn't matter for this?
Bed mass totally matters for this.
Don't you have to do brackets first?
How can you put those together? They're not like terms. So you have to distribute, like you learned in grade 9. Minus 8 root what? 15. Can you simplify any of that? No. Why not? There's no pairs. That's 3 times 7, no pair. That's 3 times 5, no pair. So it's done. I can't add them together because that is the same as 4x minus 8y. I can't put them together. They're unlike terms. What's happening over here? Can I do any simplifying? Where? 8. That's 4 times 2, isn't it? What's the square root of 4? So I got 2 root 2 times root 6 minus root 2. What do I do first? I do that, right? To get what? 2 root 12. Then I do that. What's that? Minus 2 root 4. Can I simplify anything there? I can simplify the 4 and the 12. Because the 12 is what? 4 times 3. So what happens with that 4? What do I bring out? 2. So I get 4 root 3 minus, what's the square root of 4? 2. So what comes out? 2. I've already got a 2 there, so it is 4. And I'm done. Because those are unlike terms. Because that is the same as 4x minus 4, which we couldn't do anything with. Everybody good? Yeah? Okay. Look at 8. What are you going to do in 8 before you even attempt to solve the question? You're going to simplify one thing in there. What? The 75. So do it. What's 75 break down into? 25 and 3. What's 25's? 5. So I've got root 5, 3 root 5, minus 5 root 3, plus 3 root 3. Now what do you notice right there all of a sudden? Are they like terms? So can I put them together? What's negative 5 plus 3? Root 5, 3 root 5, minus 2 root 3. And now this looks exactly like what we have just done twice. And it becomes easy. Right? What do I do with the 1 and the 3? It's 3 root 5 times 5? 25. What's square root of 25? So that's 15, isn't it? Okay. And then what do I do with the 5 and the 3? Minus 2 root. And what do I do with the 5 and the 3? Multiply to get 15. While I wait for my machine to do what it is supposed to do. Yeah? What are you going to do with number 9 before you even try the new stuff? You're going to simplify, right? What's 20 break down into? 4 or 5. What's 72 break down into? I do 36 and 2. What's 45? 9 and 5. 9 and 5. What's the square root of 4? 2 root 5 plus 6 root 2 minus 3 root 5. Can I put any of that together? Why? Because they're like terms. So 6 root 2 I can't touch, but what's 2 minus 3? Negative. Would I ever write the 1? Nope. Negative root 5. Everybody see how to do it now? Great. Try the 2 hardest ones on your own. Go. And I mean actually try it.
Yes, I will give you as many crisp high fives as you want within reason. If you finish one.
Oh, is it?
Back one on those 5. You'll call me the answer. Or you can also do yeah, I'm good. I'm good. That's good. So finish that.
Wait, is that your count?
I'm not going to calculus next year. You couldn't do a calculus next year if you wanted to. If you did math both semesters, you couldn't get calc. Get to do 2 grade 12 maths. Definitely not for math. No, don't. Lack of commitment. Look at you, Chris, don't do it. Yes, you can use a calculator. You shouldn't need to, but I'll decide it. Because in grade 10, I wanted to. It would be hypocrites of each of that.
Okay, Mr. Myers,
Mm-hmm.
when you simplify and you find a pair, but what if you have 2 other numbers?
Then they stay under there. Unless one of them breaks down again.
Oh wait, but what if one of them is 2?
Then it stays under there because 2 is by itself.
Okay.
So I assume you went to 15 and 10.
No, 30 and 5.
Okay. And then 2, 3, 5, 5. Right? Because 30 is 2, 3, 5. So your pairs are 5 and 5.
And then it's
So 2 and 3 stay under there. And what do you do with anything that's stuck together in this math? Well, when we bring out the 2, we multiply them. What do you do with what's left under there? Because you left a 2 and a 3 under there, right? What is 2 and 3? 2 times 3. That's what stays under there.
so it'll be 60 times 6.
Yeah, 60 root 6.
Wait, but that's
Hmm?
smaller than 12 and 150.
Yeah.
156 is more than 150.
Yeah. There you go. I think you're right, Carl. Let's start 7. Can I just go back?
Went to Vegas. It was okay.
That's a melancholy Vegas experience.
It was a little cloudy and roady. Couldn't really use the pool. It was cold, windy.
I went golfing in Island Islands.
Yeah? How'd that go? I thought you were going out to Saskatchewan.
Not really great.
Oh, I thought you were.
No, that's the only thing I do these days. I like golf. So, in spirit, I'm at 75.
In spirit, yes. All right. Why did I choose those numbers? Why did I use 25, 9, and 4? I used 25 and 6, 9 and 6, and 4 and 6. Why? Because they're all perfect squares, right? What's the square root of 25? So out comes a 5. What's already there? So I get 60 root 6 minus, what's the square root of 9? 3. So what comes out? A 3. What do I do with the 3 and the 5? So I multiply them to get minus 15 root 6. What's square root of 4? What do I do with the 2 and the 3? Plus 6 root 6. What do I notice? There, and there. They're all 6s. So are they like terms? So what do I do? 60 minus 15 is 45. What's 45 plus 6? 51 root 6. Now let's say you still don't believe me that memorizing your perfect squares is a good idea. Then you just break it down normally. It will just take you longer. 150, 15 times 10, 3 times 5, 5 times 2. There's your group of 2. So out comes that 5, leaving behind 2 times 3. 54, 9 and 6, 3, 3, 3, 2. There's your group of 2. Out comes a 3. 24, 6 and 4, 2, 3, 2, 2. There's your group of 2, leaving behind a 6. Does anything change in number 11? No, I'm just looking for what? Cubes. So I need groups of 3 instead of groups of 2. Right? Since I realize how few of you bothered to memorize your perfect squares, I'm betting nobody bothered to memorize their perfect cubes. So you would need to break these down and look for groups of 3. I have memorized my perfect cubes. This is 27 times 4. This is 8 times 4. And this is 64 times 4. Cube root of 27 is what? 3. So what comes out? 3. What's already out there? So what do I got? 6 cube root 4. Plus, what's the cube root of 8? 2. What's already out there? Nothing. So it's 2 cube root 4. What's a cube root of 64? 4. So out comes a 4. What's already out there? 12 cube root 4. What do you notice about that, and that? They're like terms. So what can I do with their coefficients? Add them. 20 cube root 4. Now, please listen to me. If you do not understand this step, that is something totally different than the multiplying, right? I expected you to already know that. We've talked about it a lot. We've done it a lot. But if you haven't practiced it, there's no way you're doing this the way I am, correct? Why am I insisting on showing this to you? Because this I need to save time, don't I? I need to get you guys to the point where you can do the new stuff as quickly as possible. Which is why I have still reminded you on more than one occasion that you can break it down the old school way. It's fine. But please look at how much time you save by doing a little bit of memorization. Your job for tonight is page 103. And I think yours ends at 103. Yes, you guys only have 103. So your job tonight is page 103. You have a quiz tomorrow on exponents, which we reviewed today, and on questions 1 to 6 of this page, I believe. But my computer's frozen, so I can't check. No, 1 to 4. 1 to 5. Your quiz tomorrow is on exponents and numbers 1 to 5 on page 103.
So it's gonna be the exact same question.
No, it is not going to be the exact same questions. But even if it was, a bunch of you would still get them wrong because I know this because in your measurement test, I gave you the exact same questions on the quiz, then the test, then on the cumulative. And still people did not get 4 out of 4. So I could give the exact same questions and it wouldn't matter. What?